So this is a very hard question that involves logarithm inequalities, but it's one that involves a variable in the base. So before we do this problem, I want to review something really quick because a lot of the times kids forget how to solve inequalities. So, different compound inequalities can be combined by either an and or can be combined by an or, right? So if it is combined by an and, you need to remember that means it's an intersection they're looking for. So with both inequalities, you're looking for an overlap, for an and, okay? For an or, you're looking for an union. That means you're not looking for an overlap, but you are going to add one solution with the other solution, combine them, and make a solution together. That's what an or inequality is. So let's see some quick examples, and then we'll see this problem really quick, okay? So suppose, for an and inequality example, suppose we have x is less than -1 and x is greater than 3. So I'm going to kind of graph that on a number line really quick. Okay, x is less than -1. I'm going to put -1 here and 3 here. X is less than -1 means that is going this direction. That is your solution with the open circle here. And x is greater than 3. That means this is your solution, right? Now, because they're connected by an and, you're looking for, is there an overlap? Is there an overlap between the two solutions? No, there's no overlap. So your answer here is no solution. Okay, let's look at the next example. X is less than -1 and x is less than -2. So I'm going to draw a number line again. You have -1, -2. We have x is less than -1, so that's going to go this way, less than -1, and we're doing x is less than -2. So x is less than -2 is going this way. So again, because they are connected by an and, you're looking for an overlap. So what is the overlap between these two solutions? The overlap is right here. So your answer for that one would be x is less than -2 or -infinity, comma, -2, close parentheses. These are your solutions. Okay, now let's see how the solutions are change if they're connected by an or. Okay, remember or means or is a union. Okay, which means, if you have two solutions, you need to combine both to get your full solution. So if you have x is less than -1, I'm going to again draw my number line. I'm going to put both inequalities here. So -1, 3, right? X is less than -1. That solution right here is like this. Less than -1 goes like this. Greater than x is greater than 3 goes like this. But because these inequalities are combined by an or, you're looking to combine both those into a single solution. You need both answers together. So your answer for that would be x is less than -1 or x is greater than 3. If I'm writing it in as interval notation, it will be -infinity, comma, -1, union 3, comma, infinity. Both those parts you need, okay? That's your solution. So you see how the solution is different when you have an and an or, no? Now, if you're doing x is less than -1 or x is less than -2, okay, so -1 is here, -2 is here, x is less than -1 means that's going this way, and x is less than -2 is going this way, correct? Now, because again, you're connected by an or, you need a union. You need both values to satisfy both solution in your final answer. So in this particular case, if you just say x is less than -1, that automatically contains the x is less than -2 also, So here, you can write a solution saying it's just -infinity, comma, -1. Because the x is less than -1 already covers x is less than -2. So this solution has both those inequalities inside it. And you need both those inequalities inside it if it's an OR, if it's combined by an OR. Okay? So that is a quick review of inequalities, because you need to kind of know that before you go into something this big. Now, let's talk about this really quick. Before you do any log questions, whether it's equation or inequalities, the one thing that you need to do is you need to make sure that the check for domain, okay? So you know a log function looks like this. That's your log function. So in your log function, your x values in the log function must be greater than 0. You can see that, right? There's no value that is 0 or less than included in your log function. So the domain is, when you're doing a log, the input inside the argument must be greater than 0. It must be positive. So for any log question, the first thing I would suggest you to do would be to find the domain. Okay, what do you do for the domain? You set your argument that is inside the log to be greater than 0. Your argument for this particular inequality, this log function, is this guy. No? You're going to set that to be greater than 0. Okay? Now remember, this is a polynomial inequality. This is a polynomial inequality, means you need to solve this using a sign test. You can also solve it by a graph, but I'm going to do it by a sign test now, okay? So, excuse me, in order to solve this, you need to get all your x-intercepts. So I'm going to take the x out. So I'm going to get x squared minus x minus 2 is greater than 0, okay? Again, I need all my x-intercepts. So I'm going to do x times x minus 2 times x plus 1 is greater than 0. That's your factoring for this, yeah? So now you have your x-intercepts, which means now if you put them on a number line, that's going to be -1, 0, and 2, right? So now you need to do a sign test here, okay? So I'm going to plug in, I mean, there are a couple ways you can do this problem, but I'm going to check in first with a number to the left of -2, -1. So if I'm plugging in a number next to to the left of -1, let's say I'm plugging in -2, this is going to be a negative. This factor is going to make it a negative also. And then this is going to be also a negative. So now it's going to be a negative times a negative, which is a positive, times a negative, which is going to give you a negative answer, okay? Now, of course, you can use multiplicity to figure out how this goes. Here at x plus 1, at x equal to -1, the multiplicity is 1. So if this is a negative, it's going to pass through, which means this must be positive. But of course, you can plug in a value like -0.5 and check it, okay? So I'm checking it into this function. So -0.5, that gives you a negative. And then this is also a negative. But this is -0.5 plus 1. That's going to be a positive. So a positive times negative times a negative is positive. Positive times a positive is going to be positive. And we got the same answer here by looking at your multiplicities. Now, plugging in another value. Let's say I'm plugging in 1 here. Okay. For 1, so x equal to 0, again, the multiplicity is 1, so it's going to pass through. So if this is positive, I'm going to say this must be negative. But again, you can plug in a value between 0 and 2. So let's take 1. If I'm plugging in 1, this is positive. This is 1 minus 2 negative. And this is 1 plus 1 positive. That's going to give me positive times a negative, negative, negative times a positive, negative. So your answer is negative, and I got negative here as well. Okay. At 2, again, the multiplicity is 1. It's an odd multiplicity, which means it needs to pass through, which means if this is negative, this must be positive. But let's see, let's plug in a value. If I'm plugging in 3 into this function, 3 into x, that's going to give me a positive. 3 into this factor, 3 minus 2, that's positive. 3 into this factor, 3 plus 1, that's positive. So it's positive times a positive, which is just a positive. And I had gotten a positive here. Now, this is greater than 0. So I'm looking for where the function is greater than 0. This is the function, right? Where is the function greater than 0? The function is greater than 0 here and here. So my domain, I'm just done with the domain. My domain is -1 to 0, union 2 to infinity. That is my domain. Okay, this is my domain. I need to check back with it all the time. This is my domain, which means my solutions have to be within this interval. Okay, now, because so as of now, I've only found the domain. I haven't done anything else. I need to actually do the problem, okay? Let's go back and look at the problem. I'm going to get this guy down. So this one's a unique problem because you have an x in the base. So this is going to cause a problem because remember, depending on if your base is between 0 and 1, or if your base is greater than 1, when you exponentiate it, the behavior of the graph is different, right? So if you're looking at a simple question, like log base 7 of x is less than 0, okay? If your base is greater than 1, in this case it is, if I'm exponentiating both sides, I'm going to get 7 to the log 7 cancels, and I'm going to get x. I'm going to get x is less than 1. That's going to be my solution there. But now, if this is a 1/7, okay, remember, if you have a base that is between 0 and 1, if you're exponentiating it, you need to flip the inequality, okay? When you flip the inequality, so your answer would be here, this gets canceled out, you're left with x, this less than becomes greater than, and 1/7 the power of 0 is 1. So your answer is x greater than 1. So you see your solution will be different based on, if your base is greater than 1 or if your base is between 0 and 1. Okay, so when you have a variable as a base, you need to do two cases. Case 1 would be if x is greater than 1. And then between cases, you're always combining with an or. Case 2 is between 0 and 1. Okay? Both cases need to be satisfied, and the solutions, when when you get the final solutions, you're connecting them with an or inequality. Then with an or, because case 1, you have an answer. Case 2, you have an answer. I need to combine both the answers together. So I'm combining it with an or. So you got to remember that, okay? So let's look at what happens if you have case 1. If you have case 1, when x is greater than 1, x here is greater than 1, which means if I'm exponentiating it, because x is greater than 1, that inequality is not going to flip. So this gets canceled. So I'm going to get x cubed minus x squared minus 2x is less than x cubed. Okay? And this, you x cubed, if you subtract x cubed from both sides, you're going to get negative x squared minus 2x is less than 0. And now this is very tricky. You need to bring these guys, make these positive. There is a reason for that, because if you don't make it positive, let's say you do take the negative x out here and you're going to get x plus 2 less than 0. The problem is your answers will be wrong, because if you multiply negative on both sides, you're going to get x times x plus 2 is greater than 0. So this is really what you're going to be looking at. So I would not, I always, very important, when you have a negative leading coefficient, move it to the other side before you solve the inequality. So I'm going to move it all to the other side. And so I'm going to get that inequality as x squared plus 2x, right? I added x squared to the other side, added 2x to the other side. So these guys are now here. So this is really x squared plus 2x is greater than 0. Okay. If you have questions on why that's the case, comment below and I can kind of explain it. But your answers will be different if you don't take care of that. So now take the x out, you're going to get x plus 2 is greater than 0. So now I'm going to put that on here on a number line, because this is a polynomial inequality with x-intercepts at -2 and 0. And this, if I plug in a value to the left of -2, I'm going to get, let's see. I mean, you can solve this by having the graph in your mind too, but I'm not going to do that right now. I'm just going to take -3, -3 into this function, -3 into x is negative, -3 into this is also negative. That's going to give me a positive. Okay. Now, again, you can plug in a value between -2 and 0. So let's say you're plugging in -1. You can also solve this by multiplicity, but sometimes teachers don't want you to do that. So I'm just going to do it this way. So -1, plug it into here. So you're going to get, plugging it into here, you're going to get negative. Plugging it into here, you're going to get 2 minus 1 is positive. Negative times a positive is negative. So this was positive, this is negative. Okay. Again, you can look at the multiplicity, because this is multiplicity of 1. This is going to pass through, but let's check a number anyway. Okay, if I'm plugging in 1, I'm going to get, go down. Plugging in 1 into this, I'm going to get a positive. Plugging in 1 into this, I'm also going to get a positive. That's going to give me positive times a positive, which is a positive. So this is a positive. So where is my x times x plus 2 greater than 0? Greater than 0, negative infinity to -2, union 0, comma, infinity. Okay, these two parts. Now, next step is important. Once you get your solution for this, you need to check the solution against your case, against the case restriction that you've put, against the case restriction, no? Case restriction. And the restriction that we put for this case was x must be greater than 1. Okay? So you need to check the solution against this. And when you check the solution against any domain or a case restriction, you're always combining using an and. So you're looking for an overlap. Okay? So negative infinity to -2 and or 0, 0, comma, infinity, that's this kind of thing. I'm going to kind of make that graph again. Okay, so this is your domain, right? The domain shown. And I need to connect that with x is greater than 1. X is greater than 1, like 1 is somewhere here. I'm going to connect it with x is greater than 1. So it's going to look like this. So where is my overlap between these two? So within each case, you need to connect the solution with the case using an and. So you're looking for an overlap. Where is my overlap? Here. So I mean, my solution to this is 1. Okay, I don't know what happened there. The solution to that is 1 comma infinity. That is my solution when I compare the solution to the case with the case's restriction. Okay, using an and, always combine using an and. Awesome. Now, that was just one case. Now you got to go to the second case. All right. Um, there is a trick with this, but I'm not going to do that trick now. Because I think your teachers usually would want you to show the whole work anyway. So we're going to do like as though you need to do the whole work. You don't have to, but I'm going to show it in the way you need to answer this. Okay, so this is my question. My case 2 is x is between 0 and 1. If x is between 0 and 1, if I am exponentiating it, remember the inequality is going to flip. So this is going to give me x cubed minus x squared minus 2x is greater than x cubed because my base is between 0 and 1, okay? Now, again, I can subtract x cubed from both sides, and only negative x squared minus 2x is greater than 0. Remember, you don't want to have a negative. Make your leading coefficient positive, okay? So that's when I do that, I'm going to get x squared plus 2x, add x squared to both sides and add 2x to both sides. And that's going to be like both are going to be here, no? So it's going to be facing away from the 0, right? So it's going to be this way, which now it's a polynomial inequality, x plus 2 is less than 0. That's essentially the same thing as this, right? It's the same thing as this, except before we had greater than 0, now we have less than 0. And that is the trick. It's always going to be like that. But let's do it. You need to show your work, so I'm going to just do it like this, okay? The picture, everything is the same. Where is my function less than 0? Where is my function less than 0? That is, where is my function less than 0? That's here. So my solution for that is, negative 2, 2, 0. This is my solution for that case. But remember, after you get a solution for a case, you need to combine that with, this is my solution, and to combine that with my case restriction using an and. The case restriction was that x must be between 0 and 1. So let me just plot that here. X must be between 0 and 1. Hey, this is my domain there. I mean, this is my case restriction. Do we have an overlap there? No overlap. So because we don't have any overlap, this is a no solution. My answer here is no solution. So remember, within a case, you're combining the solution of your answer with the case restriction using an and. But in between cases, and in that way, for case 1, I got my final solution as 1 comma infinity. And for case 2, I got my final solution as no solution. But now I need to combine those two guys using an or. Okay, so I have to, like, I need both answers, I need both answers. And I also need to compare with the domain. Okay, so this first, I'm going to combine these two together and I'm going to get my answer as, okay, case 1 is this and case 2 is this, and I'm combining them using an or, right? So I need both answers to be in the solution. Case 2 gave me a no solution. Case 1 gave me a 1 comma infinity. So my answer to this is 1 comma infinity for the cases. But now I need to compare this with my domain. Okay, now compare this with the domain. This is my answer for the two cases, but now I need to compare this with my domain using an and inequality. So My domain was this. Okay, so let's see. This inequality translates to looking like this. And then the domain looks like, let me just put, I'm going to first put all those things in. So I have a -1, I have a 0, I have a 1, and I have a 2, right? So this inequality translates to 1 comma infinity looking like this. This domain looks like -1 to 0, and 2 to infinity. So when I'm connecting the solution of the cases with the domain, I'm always looking for an overlap. What is my overlap here? My overlap here is, this is the answer. So my final answer is 2 comma infinity. Okay. Long problem. So I'm going to recap really quick. I went over so many things. When you have an and, you're always looking for an overlap. When you have an or, you need to have both your solutions in your final solution, okay? Looking at this problem, first thing you need to do, find the domain. That's it, set your argument greater than 0. We did that. When we did that, we did polynomial inequality, and we found our answer as this. You hold off on that, okay? Then for the problem in itself, since you have a base of x, x can be either greater than 1 or x is between 0 and 1, right? So based off of that, your inequality is going to flip. So first, I'm going to write the question down again here. I wrote the question down again here. And when your case is x is greater than 1, your inequality is not going to flip. So I got this. But remember, when you have a negative here, you don't want a negative. You need to make that into a positive. Otherwise, your answer is going to change. So bring all that to the one side. I'm going to x squared plus 2x is greater than 0. So x times x plus 2 is greater than 0. And then where is my inequality? Positive. So it's here and here. So my answers are, negative infinity to -2, union 0 comma infinity. That's what I got here. Where is my function positive, right? Now, the solution to that is, before you even move on to case 2, what you need to do is, you need to compare your solution and combine that with the case restriction with an and, okay? So the case restriction was x is greater than 1. So let's do the 2. This is my solution, which I have put here, negative infinity to -2, and then 0 to infinity. Combine that with my case restriction, x is greater than 1. I'm combining those two using an and, so I'm going to get 1 comma infinity. Okay? Do the same thing with the next case. Here, your x is between 0 and 1. So you remember, you got to flip your inequality. You have x here. I don't want a leading coefficient negative. I'm going to put everything to the other side. So x times x plus 2 is less than 0. And so this is my solution to just that portion, okay? But remember, once I get the solution to that portion, I need to combine it with the case restriction using an and. So case restriction is 0 to 1. So when you combine those using an and, you're going to get -2 to 0 is right here. 0 to 1 is right here. They don't have an overlap. You need to combine them with an and, so your answer is a no solution there, okay? Then finally, just for the cases, you look at the cases, combine the 1 comma infinity with the no solution. Remember, between cases, you're connecting using an or. So connect using an or, 1 comma infinity, no solution. I need both answers in my answer. So my solution to that is 1 comma infinity. But now I need to combine that with my domain. Whenever you're combining with a domain or restrict or case restriction, you're using an and always. So you do 1 comma infinity and the domain, combine it with the domain. When you do that, you're going to get negative 1 comma 0, union 2 comma infinity, and 1 comma infinity. Where do they overlap? 2 to infinity. So your final answer is 2 to infinity. Okay. In general, between cases, you combine using an and. Within cases, you get a solution and then combine using an, I'm sorry, go back again. When you have cases, between cases, you're combine using an or. Within a case, you get a solution, you always have to combine with the case restriction using an and, okay? Do the same thing with the other case. You have a solution, combine it with the case restriction using an and then the solutions to the two cases you combine using an or, okay? That will give you an answer, but then you always have to look back into the domain, combine your solution using the domain, using an and, look for overlaps. That is your final answer. So very complicated problem. I hope that helped you. I hope it helped you answer the question. If you have any questions, drop it in the comments.